Okay, we're going to check our balancing here. So this is our balancing wheels here. These are for doing big crankshaft grinding type wheels. Like 24-inch diameter wheels fit on here and you balance them. We're great for Harleys too. Okay, so we got our flywheel here. So we're going to take it and put our balancing shaft in here. Otherwise known as an arbor. Going to find a taper that fits. That one works. Okay, this is an S&S deal here. So I mark it so I know which way up is. So I can always repeat. A big thing about repeating my work. If it doesn't repeat, there's no accuracy. So you have to be able to repeat your work to be accurate. If you tighten things back up in the same spot each time, it'll make it accurate. Okay, so I'm not going to balance it yet. I'm just mocking it up. So, this is my pre-made balance weight here. You have to guess how heavy it is. Okay, let's see what we got here. So, for some reason they have changed the balance factor considerably on the motor from stock. So it's heavy on the rod side, light on the crank. So they drill a hole in there, lighten it up. And they drill some more holes in there too, lighten it up even further. So they made it quite a bit lighter than stock there, it looks like. So not quite that whole bolt. See how that's how much metal we need to take out of that side to make it balance. So not quite this much, but close. We have to find something a little bit lighter to use for mock-up. See, that's pretty close there, see? 7/16 stud. Okay, so that's about where that one's at. So True and Osborne balance this thing, so they use whatever they want to use for their numbers. Obviously it's not what I like, because it don't work. Okay, put this weight back in. Appears to be the same problem. Ooh, not quite the same though. Look at that. This one drops a lot quicker than I did on that wheel. So whatever they use for the balance factor, it's not even the same for each flywheel. Big difference there. This one's too heavy. Something smaller, less weight. Okay, so that's this one. So these are not balanced how I do it. So they're made for a lot lighter percentage than I'm using. That weight was made for 60% years ago for stock type components. Stock type components means stock rods like these and stock type pistons, which would be cast pistons. So let me put that crank weight into, I need that flywheel back. Let's go compare it to a stock flywheel and see where they're at. Okay, this looks like a modified stock flywheel. Yep, this is a later flywheel. This is earlier 70s. something older. It's another one of those. We know this is early, but I think this has been re-drilled, so I'm not going to call this one being stock. This one, this is a 5760. That looks stock, but there's too damn many holes for me to call that 100% stock. This doesn't look correct either. Something looks unmodified to me. This one looks unmodified. This is a stock one here. So this is an early 57 flywheel. And that other one down here was a 77. Where's that other one? This is the other one. This one here is a 60 flywheel. So this would be the correct one for a 61. This is 60s type flywheel. The other one I got is a 57. 50s style flywheel. Let's see what Harley did. Let's see if Osborne made it less than stock or more balance factor than stock. See what their plan was. Okay, so that's their one was. Okay, which one's the early one? This is the 57 wheel here. This is definitely unmodified. Only got 2 holes in it. Factory holes. Washers like new. Flywheels unmodified. So you got an unmodified part. That tells you what they did factory. Unlike a big twin, Sportsters were balanced halfway decent. Okay, let's see where my weight is on this one. Way heavy. So True and Osborne made their wheel underbalanced more than Harley does from the factory. Let's see, I need another stud of some type. Try to find something that's close to weight. Yeah, it's pretty close. Okay, that's 57 Harley's, a little bit more than what this is. Now when you make the top of the rod when you make the top of the flywheel heavier, it raises your RPM up where it shakes. You make it lighter on the bottom, it makes it shake a lower RPM. I mean higher. You're balancing for a certain area of smoothness, so when you run up 55, 60, 65% balance factors, you drill a lot of metal here, it makes it, this is heavier, that makes a higher percentage. When this becomes lighter, it's for a lower percentage, which is more like a stock motor with idles all the time. So True and Osborne took a stock flywheel and made it worse than factory. Because factory wheels are easy balance for lower RPMs. So they made it really low. Which is great if you're going to idle all day long, but if you actually ride the bike, it's going to shake more, higher RPM. Especially an Ironhead Sportster that's a higher RPM motor. And this is CH, which is even higher. Okay, let's see what this one is. Right over there. Okay, that wheel's balanced. Yeah, it doesn't move. Pretty much wherever you put it, stays put. Pretty close. It's trying to move, but it's got a little high spots it hits. Alright, so that flywheel is balanced for that. So that's a 60s flywheel. So you can see how they use the same balance factor, whether it was 60s, 50s or 60s flywheel, it's the same balance factor. So this we know was correct for that year. So I raised the percentage up to be higher RPM, so I'm taking out this much weight to bring it where I want it to be. Chute and Osborne, they're using this amount of weight, so they're further off. There you go. Quick and dirty. You're screwed up. That's what quick and dirty means around here. Okay, so what we're going to do now is we're going to rebalance these things to the weight I want to use. So I'm going to take the flywheel and we're going to work on it. Okay, so what we're going to do is we're going to tighten this up now. Okay, shaft's tight. I'm going to take our weight here. We need to press this together, so we're going to go up in the hydraulic press. Press this down into the taper so it'll stay put. You only put about a one or 2 tons pressure max. It's more like what, 1 ton. That's all you need. I got a little mark on my weight so I know it's straight up and down so I can repeat later on. So I'm going to go do that and be right back. Okay. So now it's for real. Let's see what we got. So they're about halfway. This was the one that was a little bit closer. Alright, so take a deburring tool, which is just a ball burr. I deburr all my holes because I don't like sharp edges on anything. So we're going to deburr it. Okay, so we go over here to our mill. We do a deburr job. So we deburred each hole. Now there's no sharp edges in here, which I don't like sharp edges, so I deburr things. Even the ones I put in here, I deburred them. Okay, let me put this up in here. And let's see what we got. I want to see if it's on center or off center. We have to figure out where we're going to put holes. Looks like it's slightly off center, so we got to center it up a little bit. I need to take weight off the top of the flywheel to bring it in balance, which basically makes it heavier up here by doing that. I want to make sure I'm not going to hit anything that got stupid going on over here. Okay, that should be fine. Now the more material you take out of here, the lighter the flywheel will get overall. So what I'm going to do, I'm going to put 4 holes in. I'll put 1 hole here and 1 up on top. So this one here will be balancing it in like this to center it. And then down in here, these will be taking most of the weight out. So I don't have to take out a lot of weight, but I need to take out a little bit. I got to deburr it too. Okay, so I go over here and set up the drill press. Let's see, I'm gonna put this stuff away here. What this stuff's for. Okay, so I go over here to our drill press. So I got to set this up for drilling. Precision block of wood helps. Got different drills we can use sitting right here. I got to figure out which one I'm going to use. So let's see what size Harley used. See, this is Harley's drill size. This is true in Osborne, which is 1/2 inch. This should be around 7/16, thereabout. So this one's not quite 7/16. Close though, it's trying to go in there. So I'm going to use this one. Okay, we're at slow speed. Okay, so I'm going to put holes here and here. That's what we're going to do. Okay, to get over here further. Okay, so I'll put one on top and one on the bottom. Okay, so you got 2 holes. Get 2 more on the other side. Probably put them in the same spot. And the same depth. Okay, so we got 4 holes in here. So I go over and deburr them. They don't like sharp edges. So our deburring tool over here again. Just go from one machine to the other, see? Make it simple. Blow all the chips off. So right off the bat, it looks like I didn't drill this one here as deep as I did this one. So I need to go back and equalize that. Can't have it all uneven like that. See if it was me or the flywheel. Probably me. Okay, they look more equal now. Okay, let's see what we got. Now we start balancing. So we're still pretty heavy. And we're heavy on this other side, so I got to drill this side a little bit deeper to bring it back centered. You can take equal amounts off. If you screw up, you come back and drill over here, which I don't want to do because I don't like screwing up. Okay, so alright. So I'm going to drill these a little bit deeper here, and I got to drill deeper on this side here, on this side to bring it in. I might want to put 2 more holes in there too. We'll see. If it doesn't get much closer than this, we will be putting 2 more holes in there just for the hell of it. Okay, so now you see how deep these 2 holes are. Get closer. Still heavy on that side, so I haven't drilled too much yet. It's still light on this side, that's why it's going up. Need to take more weight off this corner here still. So I want to drill these too much deeper over here. They're getting pretty deep. So I can drill these ones deeper right here. Bring them down quite a bit. Or I can come back and put 2 more holes over here. Yeah, I think close enough I can probably make it work. Pretty close. Vibrating here makes it go over the high spots. Go the other direction, see if it'll repeat where it needs to go to. Looks like it's going to. It repeated. So the metal needs to come out on the bottom down there. So which is this hole right here, we need to go a lot deeper. And the amount of material we need to remove, turn it 90 degrees. That's how much you need to remove. Not much. It's all about how fast things are dropping. Alright, so drill just this one hole here, a little bit deeper. Maybe a 1/16 max. Probably not even that much. Probably 30 thou. The closer you get, the less it wants to move. You always have little nicks and stuff on your shafts here, which are affecting us right now, because that's how close we are. See, it's still heavy over there somewhere. Means we didn't take enough. I might have moved to the second hole now. Let's see. Yeah, kind of in the second hole. Still right in that general area. A different point of the harbor here. Yeah, definitely still likes that same hole. But it's close. It's got a little nick or something it's into. See how it goes bouncing back and forth? It's on the nick. You can't decide what it wants to do. It's not enough to make a difference. You can influence by touching it. See, it's still just a tick off, but it's so stinking close. It's not enough to worry about. So you barely even touch it, it'll spin. See, you keep a nice slow spin because it's so close in balance. It doesn't really matter where it's at. So it just keeps going and going and going and going. I mean, you're getting pretty close too. You can slow that down, probably half of that. See, my finger's a drag. Gonna make a full turn? Yeah, it's going around. It'll make a full turn, see, even that low RPM. That's how close the balance is. See, it keeps right on going. Yeah, it's coming to a stop right there. And it's back to its favorite spot again. That's like one chip off. How close do you want to make it? I like one chip. Yeah. Still doing. Yep. Didn't make it. Past a high spot there. Turn 90 degrees. Yep. Tick more. At some point you go too far. Very, very close. Yep. All right, that's pretty damn close. We're within a gram, pretty easily. Okay, so that's how you do the one. So now we can do the same thing again on the other flywheel. Take this one out. See if we can get this weight out of here. Nope. Let's see if we can use this to do it. Nope. Nope. Something smaller. Let's see, we're going to use the bead on that thing with. Nut. Use a nut. Oh, it's out. Nut works good. You don't even lose it. Has a shoulder and it doesn't fall through. And it makes it easy. Okay. That's a good fit when all the tapers are jammed in there pretty good. You have to tap them to get everything to free up. Alright, so that's that one. I got this one. So all this stuff you can either make or buy. That's all backwards. I like my nut being the same way each time. It might not clear. Yep. Yep. Right on it. See, the stroke is so short it gets in the way of the nut. So have to cheat. Don't torque it as much and skew it off a little bit. Okay, we go press this one in just like we did before. So, same thing, deburr. And make sure the bottom of your holes are not got no crap in here. These fill up full of shit in here. Screwed up the balance. This one's clean because I already cleaned it. Okay, this is one way the hell out. So I'm gonna put 2 more holes in this one because I don't want to drill so deep. Okay, looks like it's off in a similar way. It's heavy on this one side slightly. Okay, so this time I'm going to put 6 holes in there because I don't want to drill these ones quite so deep. See how deep those are all? They're actually about, they're almost halfway through the flywheel, which weakens it. I'd rather have 2 more. Put another hole right here, which takes the stress off the flywheel. Same weight comes off, but it's less stress. Alright, so I'm going to put 2 holes here and 1 up here. Alright, let's go do that. Again, we can see. Okay, so all four of these are equal, and this one's a little bit deeper than this one. A little deburring. Let's see if I went too much. Deburr again. Okay, let's see if we screwed up. No, we didn't screw up, it dropped. You'd be surprised how many times I roughed a fly when it was perfect when I was done. I got about cut like 10 holes in there, about half down, throw it on a stand, didn't move. Cut out a lot of weight. Okay, so this one's pretty heavy still. So definitely got to do a lot more drilling than this. And we're still off center a little bit, so I need more off center drilling also. So I'm going to drop all these holes down, probably another 1/8 of an inch on all four, and drop this one about an 1/8 inch also on this side, and hopefully it'll center it. See how that goes. You blow them chips off each time. So quite a bit deeper. Not quite even either. Alright, still off. That's my center point. Center's still off. And overall weight is still off. We're getting closer though. Do it again. Holes look a lot more even. They're all deep. Getting pretty close. Yeah, quit moving. I think we're pretty even on the center. Yeah, we're pretty close. Okay, about equal. It's got to take equal amounts off the two holes on top. So we're going to take equal amounts off these holes, and that should get us pretty close. These holes up on top will need weight, so either two here or two there, or a little bit on all four. We'll see. I did a little bit on all four, so if I took off. It doesn't appear to be moving. Stay put. There you go. Appears to be pretty close. High-speed turn test. It's running out of balls here. Still rotating. And it's on high spots. Let's go up here and check this side. That one drops. It went high. It was going here, there. It can't be high on both sides. 180 apart. All right, it's pretty close. So there you go. So this one we did 2 more holes in this one. See, this one I got 2 holes. These ones are just as deep. We got 4 holes in there. So that's your difference. All right, so pretty much stays where we put it. All right, so they're balanced now. Okay, I'm gonna go ahead and clean these all up, and we'll be back.